Hey everyone, Mr. Enyard here. I've had some requests for a video on how to convert decimals to percentages and percentages to decimals. Also, there's fractions involved, but I won't get to really break that down in this video just because of time, so I'll do a second video that includes fractions to percentages and decimals and vice versa all the way back around. But this one's just for percentages and decimals, and there's an awesome cheat chart that you'll want to screenshot and take out of this, so make sure you pay attention till the end. All right, let's get to it. All right, so this video is going to focus on changing percents to decimals and then decimals to percents. And if there's time with the chart that I have on the rest of this video, then I will also do fractions to percents and decimals. But basic rule for going from percent to a decimal, percent is out of 100, but this is the number 12, right? 12 you think of as a whole number, even though a percentage is an amount out of 100, so it's less than a whole because 12 is less than 100. So the rule is we can take the 12, the number that's in front of the percent sign, and we can divide it by 100. So percent divided by 100 equals decimal. So what do I mean by that? Well, again, looking at the number 12. If you do 12 divided by 100, wouldn't that take your decimal, which actually exists right here in a whole number, the number 12, if it were a whole number, right, would be here. We're just going to move that twice to the left. And so the decimal for 12% is 12 hundredths, or 0.12. So again, the rule that we can use to go from percent to decimal, right? If we have a percentage and we want to put it into the calculator, we need to take the whole number part of the percent, ignoring the sign, 12%, right? We need to take that and divide it by 100. No matter what it is, we're going to divide it by 100, even if it's a one-digit percentage or a percentage with a decimal in it. If it has this percent sign, that means per 100. So by dividing by 100, we get to the decimal form in our place value language. So let's try one. Let's try 7%. What would that be as a decimal? So we're going to take 7. 7 is our number, right? Percent. It's 7%, so 7 out of 100. And then we're going to divide it by, what's our magic number? It's part of the rule, 100. Which means we're going to take that decimal that exists, but we don't see it. It's right there. We're going to move it how many times to the left? 1, 2. Now, this number, it was a one-digit number, right? Created a gap here. What needs to be in this gap? I need to fill it with a 0. I can't have nothing there. So the visual form of nothing is a 0. So the answer to what our decimal is 7 hundredths, which again, notice it's 7 hundredths because percent is per 100, so this is 7 hundredths. And so that means I don't have any tenths. I didn't even get to 2 digits, right? Because this is only a one-digit number. All right, so you try these 59% and 3%. Pause the video, see if you can figure them out. All right, so I'm going to jump into it. We're going to take each of those numbers, 59 and 3, right? So we just kind of ignore this. We do 59 and we take the 3, and we're going to divide it by 100, which of course means to move the decimal twice to the left. So where's the decimal in 59? After the 9. Twice to the left means our decimal is 0.59 or 59 hundredths. And for 3 hundredths, or sorry, yep, 3 hundredths, but for 3%, the decimal would be here. We move it twice to the left. It creates a gap that we fill with the 0. So that's going to be 3 hundredths, written like that. Okay, so what about going backwards, right? Going backwards from decimal to percent. Well, if you're going from percent to decimal and we're dividing by 100, what would the rule be? To go the opposite direction. Okay, so multiplying by 100, right? So if we're going from decimal, Okay, so the decimal to get to percent, which is the opposite of what we just practiced, right? The rule's the opposite. Instead of dividing it by 100, taking that percent and dividing it by 100, since when we look at percents, we usually see a whole number with that percent sign, we're going to take the decimal we're given and multiply it by 100. So let's say we were given the decimal 31 hundredths, and we want the percentage. How would we do that? Well, we're going to take 31 hundredths, the decimal, and we're going to multiply it by 100, which means move the decimal 2 times to the right. So we're just going to take it and go just like that, and we end up with the whole number of 31, and then that decimal that isn't necessary becomes a percentage. So 31 hundredths is 31%. Okay, so again, what if we have a 1-digit decimal, the decimal that is in the hundredths place? So this is 5 hundredths. Okay, we have a 0 here. And you hear it in the name 5 hundredths, that it's 5 out of 100, which would make it 5%, right? Not 50%. But what would we do? We would put it into our little rule formula here. We'd multiply it by 100, which means move the decimal twice to the right. So we move it twice to the right. That's my son. And we end up with 5%. All right, so you try a few. See if you can go from percent to decimal and decimal to percent. Okay, so this is my benchmark chart. These are the things you should just know. Life gets a lot easier as you're going through stores, looking for deals, trying to compare costs of things. Real life, want to know it in your head, be able to do some math in your head. This is what we would consider to be benchmark things you should know by the end of 6th grade, or just in life in general. All right, so I've categorized them as the percentages, the decimals, the literal fraction from the percent and decimal, to the simplified fraction, which we use for the tape diagram. Now, the simplified fraction, when I get to it, is what we would usually use to do the math to find a percent of something. So if we don't have a calculator where we can just plug in the decimal form, sometimes it's just a lot easier to think of it as pieces of a whole, and I'll break that down. But you may want to screenshot this, put this somewhere safe. You may want to redraw the whole thing to help you remember it. But real quickly, I'll go through just a couple of these. You can read through the rest and pause it so that I can show you how it works. So let's look at 10%. So the first one, you say the number and then the percent symbol, 10%, which is, remember, if you divide the percentage number by 100, because it's per cent per 100. Aren't there 100 cents in a dollar? So I have 10 hundredths. So you can think over here to the literal fraction. This literally means 10 out of 100, or 10 hundredths. We write that like this, 0.1, which is actually 1/10. And you can see that if I take a 0 off, I end up with 1/10. But 10 hundredths would put a 1 in the tenths place and 0 in the hundredths place, so I don't even need that 0. Now our simplified fraction, like I said, is 1/10. And so tape diagram wise, tape diagram is a rectangle. It's broken into 10 pieces, and I just have one of them. So I could use that to say if something costs 50 bucks, all right, what's 50 divided by 10? Okay, 5. So each of these would be $5, and I'd have 10 of them. So you could see that 10% is only $5 of 50. Also, though, 10% being that it's 10, you could just move the decimal back on 50 one place since you're just dividing by 10. All right, let's go to 25%. 25% is our benchmark. It's 0.25 or 25 hundredths is how you would say that. So this is the literal fraction. And the simplified fraction, though, is 1/4. Because both 25 and 100 can be divided by 25. And if you do that, you get 1 out of 4, or 1/4. Hey, isn't a quarter of money 25 cents written like that? So my tape diagram is just 4 pieces, and I just have one of them. So let's say something was, again, well, let's change it to 40 bucks. What's 1/4 of 40? Well, if you had 40 broken into 4 pieces, wouldn't each of these be 10? So it's 10 bucks.
So 25% of something you can think of as 1/4. And you just want to get, when you see 25%, that's a quarter. All right, 33% is an interesting one because the decimal would just go forever with threes because it's based off the simplified fraction of 1/3. Sometimes you'll see things that's a third off. Well, if it's a third off and you try and put that into the calculator, you're going to get this endless 0.33333, and you might see a 33%. So it's not exactly 33 hundredths, it's 33.333333333 hundredths, right? But it is 1/3, and 1/3 is just 3 pieces of a whole. All right, so if you go, let's say something's 45 bucks, and it's a third off, right? That means if I did 45 divided by 3, each of these would be 15. It's going to be $15 off, so it's going to be $30 total cost. All right, so we can use the fraction, right, of our 33%, 1/3, as our basic solving units because the decimals are going to be tricky. Same thing down here with 67% or 2/3. 2/3 is an endless list of sixes after the decimal place. So 2/3 is going to be 2 of those 3 pieces. All right, then you got 75% being your 3/4. Okay, your fifths, 1/5, 2/5, 3/5, 4/5 are 0.2, 0.4, 0.6, and 0.8. Right, just 2, 4, 6, 8. Remember that with your fifths. So quarters, thirds, half, 50%. Okay, 1/2, 0.5. That should be memorized. These are things you want to be able to memorize. So I'm going to zoom in real quick. I still haven't figured out what I'm going to do with that last column. There you go. Take you a screenshot. Save that. Remember that. Copy it, paste it, put it in something you can use for notes.
All right, I hope that was helpful. Part 2 coming up, and that'll involve fractions as well on converting those and simplifying and blah, blah, blah. All right, have a good one.